Topic for this video is algorithm for generating solution vector for knapsack problem. For 01 knapsack problem, we have discussed the algorithm in previous video where we fill up the table entries. Now we want to determine which items have been selected as a solution. So now we are discussing the algorithm for generating solution for 01 knapsack problem. There are few arguments. The first argument N denotes number of items, capital W denotes bag capacity, K denotes solution table, WT denotes weight vector. Now in solution table, the last row and last column cell, the last cell, that means the last row and last column, in that the value denotes the total profit for the solution. Now we want to identify which items have been selected as a solution. So if you analyze the table entries, so in that, let's say we start from the last cell, that is K of N W. So that value shows the total profit. Now the total profit is generated with the help of last object or not. That means the last row. Last row will say right now it is current object, current item. So now in that case we have to check the previous row same column value. So we check K of I minus 1 and J. So right now we are there in jth column. So we say in jth column we compare the current row, that is ith item, and the solution for I minus 1. If both are same, meaning to say the ith item is rejected, and that is the reason the previous solution has been brought forward in the ith row. So we say x of I equal to 0. Here x is a solution vector. So if item I is selected, we will be storing 1. If ith item is rejected, we will be storing 0. So where K of I equal K of I minus 1 J, we reject ith item. Else, that means this condition becomes false. K of Ij not equal to K of I minus 1 J. So we determine that ith item is selected as a solution. So we put x of I equal to 1. Now when we say we have selected ith item, so it is occupying some weight in the bag. So the weight of the ith item is WT of I. So we deduct the WT of I from J, which is the current capacity of bag. So we say J equal to J minus WT of I. So here we have determined whether ith is selected as a solution or not. And if I is selected as a solution, then we reduce the bag capacity with the WT of I. Now whether I is selected or not, we now move to previous row. So previous item. So we say I equal to I minus 1. So this process will repeat, will iterate till I is greater than 0 and J is greater than 0. When I becomes 0 or J becomes 0, then we stop this procedure. So what do you mean by I equal to 0? When we say item I equal to 0, there is meaning of that no item remained. We have checked nth item, n minus 1 item, n minus 2 item up to item number 1, and that is why now we reach to item 0. Item 0 meaning to say no item exists. Now when J is equal to 0, the meaning of J equal to 0 is bag capacity is 0. So we have checked for each and every possible weight for this bag. So this is how we wrote the condition here, I greater than 0 and j greater than 0. So once this loop is terminated, we have solution matrix ready, and now we display that matrix for I equal to 1 to n. We say write x of I, and at the last we display profit, write total profit equal to k of n w.